And we will begin. My name is Melissa Nolan. I'm the Pollution Prevention Specialist over here at the College of Engineering and Technology at East Carolina University at the Center of Sustainable Energy and Environmental Engineering. Welcome to our Pollution Prevention webinar series. It is titled Industrial Decarbonization, Pathways for Innovative Change. This is brought to you by and funded by the Environmental Protection Agency and, of course, the Sustainable Energy and Environmental Engineering Center, also known as CSE3. Here at ECU, we are future-focused and innovative-driven. At CSE3, we offer lots of different services. These different programs include the EPA's Pollution Prevention Program, also known as P2, and we also offer Source Reduction Assistance, also known as SRA. These different services include on-site energy, P2, and lean assessments, regional on-site P2 energy training, regional workshops, technical and engineering support, cash flow and market analysis, and return on investment. Some housekeeping before our webinar begins. This series will be recorded and there is transcription as well. Speaker presentations will be available after the webinar. Feel free to ask questions. We'll hold a Q&A at the end. And also feel free to give feedback on how we do here. Our speaker today is Dr. Kristen Cetin. She is the Associate Professor in the Department of Civil and Environmental Engineering at Michigan State University. She's also the Director of the MSU Industrial Assessment Center. Dr. Cetin leads a diverse research group dedicated to advancing smart infrastructure systems, research, and education. Her research group's work focuses on the investigation of the performance of buildings, building systems, and other infrastructure, and the development of solutions to improve the energy performance, efficiency, and energy demand contributions of the built environment. And at this time, I'll hand it over to our speaker, Dr. Cetin.
Great. It's nice to meet everyone, have the opportunity to present here. As you heard Melissa say, so the title of this presentation is on a focus on industrial decarbonization. And among the efforts to work towards decarbonization of the industrial sector, there is a need to understand how do we get from where we are today to where we need to be in the future, and what are some of the motivations as well as the challenges associated with that pathway. And so this presentation is a collaborative effort among ourselves at the Industrial Assessment Center at MSU, as well as the Economic Growth Institute at the University of Michigan, who've worked on kind of parallel efforts towards the same kinds of goals. And so we got together and put together this presentation to try to reflect on some of the things that we found that are similar in terms of this topic. So hope you enjoy it. Hope it's helpful and interesting. A few acknowledgements. So Sarah is the main collaborator here. She's a senior research manager at the University of Michigan Economic Growth Institute, and then a number of the staff in the Michigan State University Industrial Assessment Center, Juliana and Adriana, who helped compile some of the data that we used for this analysis, and many others as well, but them in particular. So what I'm going to try to do, I'll give you some background about both our efforts, so the IAC as well as the Economic Growth Institute, some motivation for why this is important, some of the challenges and some of the opportunities that we found along the way in trying to establish what this pathway can look like. We are both based in Michigan, so a lot of the things that you'll see here are applicable to Michigan and some of the things in the Michigan area, but a lot of them are also more broadly applicable to the industrial sector as well. Okay, so a little bit of background so you know who's speaking to you about the IAC as well as the Economic Growth Institute. So there may have been some other presentations from IACs in this series, I'm not sure, but if you're not familiar with the program, this is a program that's been longstanding through the Department of Energy, and it's all based at universities. And there's two primary goals of this. One is to support small and medium manufacturers, and the second is workforce development, and I'll talk about those briefly in a minute. MSU is one of the 37 different centers that are currently in operation for this cycle, and that switches around slightly throughout each 5-year cycle. So we generally support the Michigan area and some of northern Indiana and Ohio. Brief background about the IEC program. It's been around, started in the 1976 in the Department of Commerce. Then since 1978 has been housed in the Department of Energy. And initially the primary focus was on reducing costs and improving energy efficiency in the industrial sector. And since then has been more broadly applied in terms of the assessments that are conducted to support productivity improvements, waste reduction and pollution prevention, cybersecurity and smart manufacturing focused, as well as energy management systems like ISO 50001. And it is part of a broad group of types of Department of Energy funded efforts. So the IEC program focuses generally on small and medium manufacturers. We also have a focus on commercial buildings more recently in this cycle. The Better Buildings program is focuses on commercial buildings. Better Plants is for larger industrial facilities. And then there's also the manufacturing extension partnerships and the CHP TAP programs that help support specific applications of manufacturing. So we collaborate with those and help support one component of the broader effort from the Department of Energy. In general, the kinds of things that you'll hear from this are stemming from our efforts to conduct energy assessments of about 30 manufacturing and a smaller number of commercial buildings every year. And that's for all of the centers, but ours in particular does 30 a year. And these, like I said, are focused on small and medium manufacturers. So there's some criteria that are listed here that make those qualifications. So there's the energy bill, sales, and employee qualifications. And then we also do a number of commercial buildings, which are generally on the medium to smaller size. So that's the kinds of manufacturers that we work with. And then the second or secondary goal is workforce development. So we involve students in every aspect of what we do, and that includes hands-on participation in all components of the energy assessment process, from recruiting and finding companies interested to conducting the assessments to writing up the reports and reporting out on those, and then following up with all the companies we work with to understand what's the implementation of those recommendations. So past 2 years, we worked with about 50 students and look forward to more. So that's a bit about the IEC program. The Economic Growth Institute is housed at our sister institution at the university or other public institution in Michigan, University of Michigan. They have 3 primary focuses. They also focus a lot or do a lot of work with the industrial sector. The first is supporting companies, and this is through providing programming and funding and resources to help support economic growth. The second is more for communities, for government organizations, and for nonprofits. And then the third, which is where Sarah, our collaborator, is housed, is on the research side and the more training side. So she, as a part of this effort, is a research manager that helps manage some of the research efforts to support economic growth, generally in Michigan, but also more broadly. So that's a bit about the program, so you know what where we're coming from. The reason that we focused on this, or trying to understand the process of how we can get to a roadmap or a pathway to decarbonization in the industrial sector, is what we'll talk about here for a second. So why is it important, and where is there the opportunity? And if we zoom out for a second to look at the U.S. overall, we recognize that the industrial sector is a big portion of our greenhouse gas emissions. Now, it has declined somewhat in terms of the overall emissions that have come from the industrial sector since the 90s, about 20-something% since the 90s. So there's a significant effort to work towards it, but there's still a lot more that we can do. And then the other thing to keep in mind, and this information is specific to Michigan, but doesn't have to be, many states, including Michigan, the industrial sector is an important part of the economy. And so when we're working towards decarbonization, we need to keep in mind that we need to, at the same time, encourage more manufacturing and encourage more support of the manufacturing space, and recognize that need to maintain that in order to support the economy. So in Michigan, in particular, when we look at where the breakdown of emissions and the targets for Michigan, and guessing other states are similar in terms of what their targets are, the industrial sector is a good component of the emissions overall in the state. Now that has decreased some over time, as with the rest of the sectors, but still we have substantially more to go. And this is primarily coming, if we look at the breakdown of this, coming from the fossil fuel combustion of carbon dioxide on site, as well as some of the other specific industrial sectors. So as we work towards this, important to keep in mind those are where our primary sources are coming from. So if that's our motivation, you'd think, okay, what are the key components that we need to work towards decarbonization in the industrial sector? And if you look at the decarbonization roadmap that the Department of Energy came out with, as well as the one that was created as a part of this effort we're talking about today, the roadmap specifically for Michigan, there's really two key components to this. The first being the technology has to be there and available to be used and make sense, proven to work. And so the kinds of things in the industrial sector that have generally been recognized as important to decarbonization are things like the energy efficiency of the building itself, which is a lot of what we do. And then other things on the source side, things like fuels that are more low carbon fuels like biofuel or potentially hydrogen, more developing efforts there, as well as things like on the other side, which is if we are emitting carbon dioxide or emissions, can we capture it, store it, use it? Or can we adjust or fuel switch to other things more on the electrification side or renewable energy to support reduction in the amount of fossil fuels and emissions on site that we produce. So if those technologies are present and available, that's one component of it. The second component, and really what the focus is of this effort, was the second part, which is the motivation and the drive and the willingness to actually do this in the industrial sector. And that's the focus of this, and what I'll try to speak to in the rest of the presentation is what are the motivations for those that are moving towards decarbonization, and what are the things that are preventing that, or the roadblocks, and what is the willingness overall of some of the manufacturers to adopt these things, and where do we have to take that from here to move forward. So the first thing we wanted to do to preface some of the data we've collected is try to understand what historical data tells us. So what is it what technologies and what efforts have already been successfully completed in manufacturers that we've talked to and worked with on this effort. And so in order to understand that, and you'll see this throughout the rest of the presentation, we have data collected from both ourselves for the past year or so of discussions with about up to 40 manufacturers that we've worked with the past year or so. And then the 40 manufacturers that the Economic Growth Institute also talked to as a part of their clean energy technology adoption roadmap. So you'll see results in here associated with both of those efforts. The main thing to keep in mind is with our efforts, we focused more on small and medium manufacturers, since that's the group that we generally target. And the University of Michigan effort includes a more broad spectrum of industrial manufacturers, so larger manufacturers in particular are more represented in that group. So you'll see some results from both of those things. All right, so what's been done so far? So every time we work with a company, we ask them to understand what they've done so far, if anything, to support decarbonization or energy efficiency in their facilities. And if you look at the bars here, I realize the text is very small, but if you're at a computer, hopefully you can see it. If you look at the bars here, the largest bars fall into the lighting category. Almost 90% of the companies we've talked to have done something to upgrade their LED lighting, either in part or in whole of their facility. And then other top categories of things beyond lighting include compressed air. So things like upgrading compressors or identifying leaks and doing leak studies, or process type loads, followed by heating and cooling systems, things like upgrading HVAC systems to more efficient systems or replacing them. So there are definitely things going on, definitely efforts that are ongoing. And when we talk with companies generally, incentives are partially the reason that those things have been done or they've been aware of. So these are done even before, when we work with them, an assessment is completed. So these things are catching on and being completed in facilities. If you look at what the Economic Growth Institute found, they found something very similar across a broader range of companies. About 71% of the companies had done something to work towards decarbonization, and similar kinds of areas, things like compressed air and leak studies, variable frequency drives, to help support improvements in efficiency. But at the same time, in both the data that we collect as well as what the University of Michigan has found, there's a large portion of things that the companies know they could do and even can be cost effective to do so, but they haven't implemented for various different reasons. So, and they'll show some data there in a minute to explain that. But point being that even with assessments being completed and analysis being done, not all of the projects that have good potential and even economically viable are being done. So just some national level data, if you look over the entire data collected by the Industrial Assessment Center on a typical energy assessment, there's about $120 to $140 or so $1,000 in yearly annual savings that is estimated to be possible and have a payback period of about 5 years or less, based on these recommendations that are identified during assessments. But on average, about 50% of those are implemented, average about $45,000 in savings, so about 3% in savings. So there's definitely things being implemented, and that's a very positive thing, but not the 8 or something percent average that we see across the potential recommendations. The kinds of things that are being implemented most commonly, if you look at this data, are things like steam, and this is for the past at least 50 recommendations. The largest number are in steam traps, water leaks, air leaks, compressed air leaks, cleaning and maintenance programs, things that have pretty low payback periods and a decent amount of savings in the thousands of dollars range. So those have pretty high implementation rates. And then if you look at the most recent years, the types of recommendations change slightly that have been implemented, but things like lighting come to the top, as well as compressed air leaks remain there. Solar has become more commonly recommended in the recent years, and things like power factor correction to help improve the efficiency of the electricity that's being used. So these kind of things are common recommendations the past 2 years. And in terms of what's most implemented, the investment on average across the different recommendations that have been made is somewhere between a few thousand to tens of thousands of dollars per recommendation. Again, about 50% overall. Things like lighting come to the top, demand response, compressed air systems, and insulation. So what we see here from this data is that there is a lot being done, but there are a whole lot of larger recommendations that are not being implemented that have some opportunity to figure out why aren't they being implemented and what can we do to help support those things. And here's some examples of the fairly large ones that can take some time to implement. Things generally in the waste heat recovery area are ones that have the largest energy savings potential, and you know, 10 to 20, 30% in terms of implementation rate. So there's a lot of opportunities. Some things are being done, but there's still more that there's opportunities to complete. So what we need to understand is where has the motivation for this come from, and where are the roadblocks to preventing further efforts. So let's look at that now. We're going to use the same data that we've collected over the past number of years to help answer this question. So again, same data, try to understand for the small and medium manufacturers as well as the broader manufacturers. So interestingly, if you look at what we found from asking manufacturers why they're interested in decarbonization, the key takeaway I think that we've seen is that especially for larger companies, climate action plans or climate goals, sustainability related goals come to the top in terms of reasons for wanting an assessment or wanting to look towards decarbonization. And then second and third to that, not surprisingly, are cost and energy related reduction, followed by specific interest in carbon neutrality or CO2 emissions reduction, as well as some others. And then recycling, pollution prevention, these kind of things fall kind of in the middle. So it was interesting to us to see this, especially it came out more in the larger rather than smaller manufacturers, that this was an interest and motivation. Historically, the motivation from the IECs have seen has been more on the cost side. So interesting to see that this is coming up as something that's of interest. And that's consistent with what the University of Michigan found. About 50% or so of the companies that they surveyed had requirements to by the customers that they provide components to focus on decarbonization goals. And similarly, about 50% of those have publicly available commitments to sustainability or decarbonization on their website that they're working towards. And I'd say this is pretty consistent with some of the smaller manufacturers that we've seen that are part of a larger parent company that are pushing their individual plants to work towards goals, almost have like competitions between the different facilities to work towards that. You see here on the bottom, the larger companies have a larger percentage of them having this public commitment to sustainability or decarbonization compared to some of the smaller ones. The other thing that we wanted to look at for motivation is to try to understand, since cost and energy savings are a big component of this, is to understand what the breakdown of costs looks like for the companies that we've worked with. And so we did some analysis to understand, based on the utility bill analysis we conduct, what does this look like, or what are the driving costs for wanting cost reduction and energy savings reduction. And so for the ones that we've looked at, the driving factor, the largest cost is for electricity, followed by natural gas. But we also noticed that there's a large number of those companies that have an even larger portion associated with a portion of cost associated with electricity compared to natural gas. So this may be different in different parts of the country, but in Michigan, this is what we've found. And then we tried to break the electricity down, since that's a large portion, to understand where that electricity costs are coming from. And so we found that most of it generally from electricity consumption itself, but demand also plays an important factor. And we've definitely had some companies we worked with where demand was much larger than the total electricity costs. But overall, on average, this is coming mostly from consumption, about a quarter from demand, and then some other costs as well. So that helps us to understand where to target and where there's things that are needed. The next that came out from discussions was that payback period in the cost category, or discussion on cost reduction. Payback period is critical to being able to make an argument for the company proceeding to implement some of these recommendations and implement some decarbonization related efforts. So among the companies we've worked with, we asked them how many years payback period is acceptable, and that on the left is the target payback, and on the right is the acceptable payback period. And we generally found that there's a number of companies that don't have a specific payback period that's acceptable, especially when carbon and decarbonization related goals, sustainability goals, come into play. But of course, overall, a good portion of them would prefer smaller rather than larger payback periods. Most, about 50%, wanted a target payback period of less than 3 years, versus majority have a acceptable payback period that may be more than 5, especially under certain circumstances. This is pretty consistent with what the University of Michigan found, though because they worked with some larger manufacturers and a broader diversity, they found a bit larger spread, especially on the ones that wanted smaller payback periods. And the key thing that came out of what they found was that the business case is critical to making this happen, and I'd say that's consistent on our end as well. So key takeaways from this kind of motivational side is that cost and energy, which historically have been kind of the primary factors, are definitely still very important, but there's also some sustainability goals that come into play in working towards this and the motivations for doing it. There's a few other things that came out of the roadmap discussion, and those are listed here. Just to highlight a few things, some of the motivations came out of government regulations, or requirements from customers, things that people that are purchasing the items that are being manufactured, or incentives. So if there were incentives out there to help support things. Mentioned motivation and business case already. The chain of command component here was if there was somebody, especially at higher levels, that was on board with things that was supporting these kinds of efforts, that helped. And then capacity. So a lot of, especially the smaller companies, don't have the capacity or time to think about it, and they may have assigned somebody to work on sustainability related goals, but that may not be their primary effort. And that was one thing as well, which impacted some of the components of the adoption process, or the motivation for these things. So that's the motivation. The next thing that we wanted to understand as a part of motivation is if there were other things that could be used to help motivate companies to support decarbonization efforts, what kind of things could those be? And so we're in the process of finishing this, but I thought it might be helpful to report out on some of the results. So what we've done is to randomly sample and interview manufacturers from a diversity of different sections or components of the manufacturing sector, to understand what kinds of what we call non-energy benefits would also be helpful to understand their interests or their motivation to work towards decarbonization. One thing that we felt was important here was that the term non-energy benefits wasn't necessarily the most helpful thing to use to discuss this, but most people were familiar with it, but the term may be a little bit not familiar in some cases. But the data is more interesting, so I'm going to move to that. So among the companies that we've talked to so far, the kinds of factors that they stated would be helpful if they were co-benefits to working towards decarbonization efforts are things to help improve productivity and product quality and reliability. So anything to help support their bottom line, as well as things more on the people side. So things like worker safety or morale or happiness of the workers in the plant. So those are interesting. We'll continue to collect data. I think we're up to about a little bit, maybe almost twice that now in terms of number of companies we've talked to, and continue to report out on those things. The other thing that we found as a part of this was we asked them if they had implemented any of these decarbonization efforts, energy efficiency efforts, what kinds of non-energy benefits have they seen? And interestingly, these are slightly different in terms of what's been helpful. We still see the worker safety, the morale of workers, the kind of benefits on the people side, but some of the others, the productivity side of things and the bottom line, are not things that generally were reported to be beneficial as a result of implementing some of these things. The other thing that we saw is that lighting came up as having quite a few non-energy benefits. So things like productivity improvements and helping with worker safety and morale, just having a brighter place to work was something that was overall seen as having quite a bit of benefits. So that's a work in progress. But anyway, that ends that section. So if those are the motivations, we also need to understand what are the barriers to the process of adoption. So this next section will talk about the process of approving and adopting decarbonization efforts to understand where there are roadblocks as a part of that process. This is a part of the Michigan Healthy Climate Plan, or My Healthy Climate Plan. It's specifically part of that roadmap discussion. Okay, so among the companies that I talked to, so you understand the breakdown, this is kind of the range of different people that are a part of the results that you'll see in the next slide. So some small and medium, some larger, some more on the consulting side. So what did we find? If we look at the clean energy adoption process, this is the middle one, to understand those different components of the process of adoption. This is what we're going to step through now to understand where there's roadblocks as a part of that process. Okay, so in the interviews that were conducted, we asked them, how do you adopt, or how do you get from being interested in an energy efficient or decarbonization technology, and how do you get to the end? So among the different stages, there's really two components. The first is the initiation phase. This is initiation of the efforts, and the second is the implementation. So I'm just going to step through each of those, and then I'll talk about the roadblocks. So the first is the agenda setting. So this is when the company decides that they want to prioritize something in the energy and sustainability space. This could be driven by any of the different factors that are mentioned at the bottom here, and some of the things we brought up earlier. But if they've determined that this is something that is on their agenda to focus on, that's the first step in the process. The second is matching. So this is finding a solution to the agenda or the need for energy or sustainability improvements. The third is redefining or restructuring. So this is trying to figure out, based on whatever technology they've picked, how can that fit in with the company, and do they need to change something about it to get to a solution that will work for their particular application. Then need to figure out who's leading that process. This is trying to figure out, is it the sustainability manager, who needs to be involved, and who's going to see it to the end, and where the responsibility of everyone falls. This is where we heard some things related to hesitation to participate or cooperation issues among different groups in the company. But overall, this is the next step, right? And you figure out who's leading it and making sure that it's a part of that process. So that leads you to actually implementing it. And then in companies that were successful in generally embedding this clean energy adoption into their company culture. This is really like kind of the final step of seeing this process to fruition. So if any of you are familiar with ISO 50001 for energy management, it's the same kind of thing. You have to integrate the technology and energy efficiency process into everything that you do, from purchasing to on the floor to all the decisions that are made. So considering those different steps, what was found from this effort was a few gaps or challenges in the adoption process. And I'm going to step through each of those and then we'll finish up. Okay, so I'll show them here. Can have them all at the same time. So there's 5 different areas that were identified as being challenges in the adoption process. And I'll try to explain each of those briefly here. So the first is lack of requirements or penalties. So as a part of the adoption process, if there's not enough requirements either at the government or state level, or penalties for not considering it, there may be some lack of even getting this process started in the first place, which is not surprising. The second is the knowledge and skills needed to figure out what technologies are needed. So what can solve some of the problems that are occurring, and what are those problems in the first place. And some of this comes from either limited knowledge or that knowledge, especially in larger companies, being siloed between different groups. The third is funding to support implementation. We see this especially with smaller companies, but larger ones as well. If there's not enough funding to make a good business case for it, then it can't happen. And especially companies that don't have a lot of larger support, say from a parent company, we see this quite a bit. The third is workforce capacity and capabilities. So as you mentioned earlier, if there's somebody that's tasked at doing this kind of thing, but it's not their primary focus, then things can fall by the wayside if it's not the main thing that they need to be doing. And then the third is having objective advice and insight. So if there are things that want to be done, the companies that we've talked to suggested that they sometimes don't necessarily trust the information that they're getting, especially it's from somebody that's trying to sell them something. And so the need for objective advice and collaboration is something that would be helpful. Okay, so as we move to kind of the final category or final results of everything, it's important to keep in mind kind of where we're at with different kinds of technologies. So if we look at this adoption chart and we think about where different types of adoption is, things like fuel switching or different kinds of fuels use that's not our traditional natural gas and electricity are very much in the like innovative side of things. Very few companies looking at it, whereas we see things like process efficiency and energy efficiency type measures being much more in the early to middle majority of companies. So with those things in mind and keeping those kind of challenges in mind, the question is, what do we do next, or what's kind of the next steps to make this work? So a few things that have come out of the discussions that both of our teams have had to try to recommend what is a good next step or pathway towards more adoption that overcomes some of these barriers and supports the motivations. So this is a kind of nice diagram to show some of those things, and the yellow components are meant to represent things that came out of discussions that would be helpful to have around. So things like industry-led collaborative efforts. So being able to talk with other industries together in the same room to understand what's being done can be helpful. Technical assistance programs like some of the ones that currently exist to have more objective advice and information, and be able to point companies to the right resources for implementation, and helping match the right technologies to the needs of the company. And then in addition to that, when we think about technical assistance programs that are available. The IAC program is one of them, and that's, at least in the state of Michigan, one to support things. And those come along with things like implementation grant funding to support implementation of some of the recommendations that have been made. So that kind of provides both the objective advice as well as some of the reducing some of the barriers to cost for adoption. In Michigan, and I'm guessing in other states as well, there's also state-led efforts to support technical assistance beyond the IAC program that kind of parallel those efforts, which are also good, supporting agencies for either local funding or at least more technical assistance beyond what the IAC program provides. For larger companies, there's the Better Plants program to support having a technical advisor meet and work with manufacturers. And then this is just one example, but there are, through the infrastructure, bipartisan infrastructure law and other recent efforts, a bunch of different types of potential opportunities to support energy savings and improvements. And then the other thing, of course, that we mention and discuss is that local utility companies are also often supportive of rebates and incentives to support these efforts. So with that, I'm going to finish up, kind of in summary, try to identify what some of the motivations and barriers are, and then kind of a pathway to help support things moving forward. And hopefully some of the things we found can be applicable more broadly beyond Michigan, even though that was our initial focus. So this is the information about our collaborative efforts, if anybody's interested. So thank you for the opportunity to present some of this.
Awesome. Thank you, Dr. Cetin. And Dr. Cetin, if you want to click to the next slide.
Oh, shoot. I'm sorry.
That's all right.
I didn't know I was supposed to. Go ahead.
If you could go back one more.
Oh, is this
Thank
what
you
you
so-
want? Yeah.
Yeah, perfect. Thank you so much. Well, wonderful. Thank you for joining us today. We're going to do some conclusions and then we'll hold a Q&A session. Wonderful webinar today. Thank you again, Dr. Cetin. So informative. And, you know, as things are kind of applicable in Michigan, they're applicable everywhere. So wonderful. If you enjoyed this webinar, please join us next time for CSE3. We'll be hosting another webinar on Tuesdays, December 5th from 2 to 3 p.m. Eastern Standard Time. The topic is energy efficiency in manufacturing enterprise, presented by Dr. Sanjeev Khanna. So you're welcome to follow the link there or scan the QR code. This PowerPoint will also be included when I do an email out for all those who've attended today, which will have that information as well. And if you could click one more, Dr. Cetin, thank you so much. Of course, some promotion here. Please feel free to follow CSE3 on social media. Our LinkedIn is always active at ECU Center for Sustainable Energy and Environmental Engineering. Our Instagram is very active as well at ecu.cse3. And of course, Facebook as well. Feel free to scan the QR code for our link tree to follow us and our website and all of our other activity. We'll be offering other webinars through December and then into February, March, and April into the spring. So we would love if you also joined us for those as well. At this time, I'm going to open up our chat here. And if anyone has any questions, feel free to type them in and me and Dr. Cetin will be happy to facilitate. And if you have a question down the road, of course, we'll have Dr. Cetin's contact information in our follow-up email. So Chris asks, any recommendations for resources to find newer technologies available that can help companies with energy reduction?
Yeah, good question. I guess it depends how you define newer, but resources in terms of understanding what kinds, like the range of different technologies that are available. I'd say the best resource we typically direct people to is the Better Plants program. They provide a whole bunch of resources related to each of the different major energy consuming systems in an industrial building, and talk about what are the strategies and what kinds of technologies have been used, and they have case studies as well. So I'd probably recommend that first because it's a kind of broad spectrum of things. Beyond that, they also have some like resources that are listed there as well. So yeah, that's probably the first thing we would typically do if there's a question about a particular type of technology, because it's still through the Department of Energy. It provides some more objective information. And then there's also, depending on what kind of technology that you would like, if it's something more specific, like waste heat recovery or CHP, something like that, there are specific technical assistance programs available for those. So that'd probably be my initial thought. There's also state-based organizations and programs that do this in every state. So I'm guessing there's something available everywhere.
Awesome, thank you. Timothy asks, how many companies were included in your survey?
Yeah, so for what you saw here, it was, depending on what the question was, it was talking about, is between 30 and 40 from the companies we worked with. So it was the past year worth of efforts, either for initial assessment discussions or the assessments that we've conducted. For the information that it presented related to the Economic Growth Institute, that was 40 companies, and it included kind of broader range of both larger and smaller manufacturers, whereas ours was more smaller ones, but pretty wide diversity of types of manufacturing. Of course, Michigan might be more biased towards the automotive industry than a lot of other states, but we still see a broad range of things as well.
Awesome, thank you. And if anyone has any more questions, we do have a few more minutes. Chris asks, in your opinion, what is the best strategy to get a company on board to implement an energy conservation project? This is a good one.
It's a loaded question. Good question. I'll offer my perspective, but I'm guessing this is quite different depending on the kind of company you're working with. In terms of historically in the Industrial Assessment Center program, as I said before, this has primarily been driven by cost. So if you can make a cost argument that this is going to pay back in a short period of time, it's, I think, the easiest way to get it across. Like if you can demonstrate that based on some calculations that this is going to be cost effective and support the company's, money, right? Money is always a big thing. I'd say that's the primary thing to focus on, is if you can show that there's some of different types of energy efficiency improvements that can support that and show that can be successful. That's got to be the first step. And if you can get through that, then maybe there's other things that can be done that are maybe not quite as great a payback period, but still support things. And then maybe there's other benefits like emissions or pollution prevention or waste or whatever it might be that can also be helpful and support the other benefits besides cost. So that'd probably be my initial thing. And that's often what we hear with maybe a subgroup of the companies we work with, that somebody in the company or maybe multiple people really wants to work towards sustainability related goals, but they need something to tape to upper level management that says, look, here's a report and it shows these things, and this is going to help, reduce our costs. And why can't we just do this? This is going to be something that's written and provides a objective set of evaluation for the plant. So I don't know, that would be what I could initially think.
And that cost benefit's always a great incentive for some folks. So
speaks louder than most other things. So.
Yes. So.
Yeah.
Awesome. Thank you. Is there any other questions? I think we're nearing the end here. All right, well, I think we're all set for today. So at this time, I'm going to stop our recording, and you will see an email from me with this information later. Of course, if you have any follow-up, feel free to reach out to Dr. Cetin or myself as well, if you're interested in any services CSE3 provides. But thank you all for joining us. I hope this was insightful for you, and I hope you all have a good afternoon. Thank you.